Good afternoon. Again, as some of you have asked me questions, I thought I'd go ahead and get started with making this video and explaining the homework problem. In this chapter, we're covering long-term assets, and the homework problem talks about depreciation methods. So let's take a look at the exercise we have and first read through the exercise and then see how we set up the problem. In problem 7-5A, we have University Car Wash that's built a deluxe car wash across from the campus. The new machines cost $270,000. This is the original cost. It includes the installation, so this is the total cost. The company estimates the equipment will have a residual value of $24,000. Residual value is also called salvage value. This means this is what they can sell the machine for at the end of its useful life. The company estimates that it will use the machine for 6 years or about 12,000 total hours. So they're measuring the usefulness of this asset in terms of life, 6 years in terms of time, and in terms of working hours, it's 12,000 hours. They've asked us to prepare a depreciation schedule for 6 years using the following methods: the straight line method, double declining balance method, and the activity-based method. For the activity-based method, they've given us the activities for the 6 years. So we'll get to that in a second. So what I'm going to do over here now is, I've already copied down the basic information. The original cost of the asset is $270,000. The estimated residual value is $24,000. The life is 6 years. It's going to be operational for 12,000 hours. So we have 3 different methods: the straight line method, double declining balance method, and the activity-based method. The basic information remains the same for all methods. So I've just copied that over 3 times. So let's start with the straight line method, which is the easiest method. We calculate the depreciation, the rate of depreciation, as 1 divided by the life of the asset. The life is 6 years. So 1 divided by 6, that's how much I'm going to depreciate each year, 1/6. So basically, I'm saying that whatever is the amount I want to depreciate, it's going to be evenly distributed over the life. So it's 6 years life, so 1/6 each year. So the name straight line comes from, if I were to draw this on a graph, if I plot all my depreciation expense, it's going to be the exact same. When I connect the dots, it's going to be a straight line. That's how we get the name straight line. So let's see what we're going to depreciate. In this method, we depreciate the original cost minus the estimated salvage value divided by that estimated useful life. So we have 270,000 minus 24,000 in the numerator. In the denominator, I'm going to put 6, that's the life. So 270 minus 24, that is also called the depreciation base. That means that's how much I'm going to depreciate over 6 years. And that number works out to 41,000. That number is going to stay the same for all 6 years, 41,000 each year. That's a straight line method. So that's relatively easy, the straight line method. So if you ask me what's the depreciation expense in year 1 or year 4 or year 6, the answer is the same, 41,000. I do the calculation once and I can just set the journal entry up for all 6 years. Now let's move on to the double declining balance method. The double declining balance method, the name double, let's see what we do in the rate of depreciation. What we do over here is, you take the information you have from the straight line method and you multiply by 2, which is why I've done this calculation over here. So I take this 1/6 and I multiply by 2, and my rate of depreciation is 1/3. 1/6 multiplied by 2 gives me 1/3, 1/3. That's the rate of depreciation I'm going to use for all 6 years. Here it was 1/6, here it is 1/3. But there's a difference. Okay, several differences. Let's start with the important note I have over here. The important note is, ignore the residual value until you get to the last year. So here we said original cost minus estimated salvage value. That's not what we're going to do here. We will start with the original cost. The original cost is 270. In the first year, I'll depreciate it 1/3. That gives me depreciation expense of $90,000. 270 times 1/3, 90,000. The ending balance I have is 180. That is the original cost of the asset minus accumulated depreciation. I've accumulated 90,000 so far. It's 180. The beginning balance next year is 180. 1/3 of that number will be depreciated. 1/3 of that number works out to 160. What's the ending balance now? 180 minus 60. My ending balance is 120. That becomes the beginning balance for the following year. 120 times 1/3, the depreciation in year 3 is 40. And the ending balance is 120 minus 40 is 80. Now I'm going to just highlight and show you all the other numbers that we have over here. So it basically follows the pattern. So when I set it up in Excel especially, it's very easy. Once I set up the formula, I can copy and paste it all the way through. Now, if you recall that note, I said ignore the residual value until the last year. We have now come to the last year. So let me highlight this over here and show you what we are looking at now. I've now come to the last year. In the last year, I need to look at this number. If I continue the depreciation expense the way I had done before, I depreciated 11,852, dropping the ending balance to 23,700. What did I say? I want the residual value to be 24,000. So over here, what we're going to do is we're going to say, this is not the number I should be using. It should be 24,000. I'm going to plug the number in. Okay, so this number, I'm going to put in a different color so we see it, is the same as this number. Okay. My beginning balance was 35,556. I want the ending balance to be 24,000. Therefore, the depreciation expense should be, I need to depreciate it exactly 11,556 in order to come up with this 24,000. Therefore, this is not the depreciation number for the last year. So for the last year, the depreciation expense is a plugged number. I work backwards. I say I want the depreciation, my ending balance to be 24,000. Therefore, this is the number I want it to be. Now, the advantage of the double declining balance method in ignoring this residual value is I don't know what's going to happen over 6 years. Am I likely to get more or less at the end of 6 years? Time will tell. So at this point of time, at the end of the 6th year, if I decide that I can't get 24,000, I can get the best is 20,000. So I'll change this number to 20,000 and show you what happens over here. I change the number to 20,000 and you will see my depreciation expense is more. It's 15,556, saying I need to depreciate it more. But for now, they didn't give us that information, so let's leave it at 24,000. So for the last year, the depreciation expense has to be adjusted. Once again, you start out with the straight line method, the rate, multiply by 2. Once you get that, you put this in the column for depreciation rate. That stays the same, 1/3. Start with the beginning balance is the original cost of the asset. We ignore the salvage value when we start up front. Keep calculating the depreciation expense on the beginning value. Ending value is beginning value minus the current year's depreciation expense. Now the declining balance method, we are applying the 1/3. The rate is the same, but we keep applying it on a lower balance, which is why my depreciation expense also is dropping year after year. Okay, so now let's move on to the third method, which is the activity-based method. The activity-based method, the formula looks similar to the straight line method, the numerator, but the denominator will be different, and let's see what it is. In the denominator, instead of life in years, we have life in terms of the activity. Here they're telling us hours that I'm going to use the machine. So here my depreciation expense is calculated as 270 minus 24, that's in the numerator, same as we had over here, divided by 12,000. This number that I come up with, $20.50, this is per hour. This is per hour that I run the machine. I use the machine. That's a depreciation. So now what I need to know is, how much should I use the machine each year? I have to wait until the end of the year. And at the end of each year, they told us how many hours I use the machine. These numbers that we had that were given to us in the problem, now we are going to use those numbers. So I bring those numbers over here. I've just copied the numbers over. If you add them up, you will notice it's the exact 12,000 hours we anticipated to use it. The rate of depreciation we already calculated. It's going to be $20.50 per hour it's used. So in this method, the more I use it, the more I depreciate it. The less I use it, the less I depreciate it. We'll see over here. In year one, I used it 3,100 hours. Therefore, the depreciation expenses $63,550. It's 3,100 times $20.50. The second year it is 1,100 hours, so 2,000 less. Multiplied by the same rate, the depreciation expense is going to be smaller. So here it's based on the actual usage, the actual activity. Your depreciation will either increase or decrease. The total depreciation expense is 246. That's the 270 minus 24. So we were asked to create a schedule. A schedule is simply basically saying in a table, lay out the depreciation expense. Straight line method, the answer is 41,000 for all years. For the double declining method, you will take the numbers from this column and you'll put down the numbers for the double declining balance method. And for the activity-based method, you're using the numbers over here. And this is depreciation expense. Let me correct that. So the depreciation expense is given over here. So once again, depreciation expense, when you're creating your schedule, the final numbers that we're looking for depreciation expense for straight line method, 41,000 for all 6 years. Depreciation expense for the double declining balance method, you need to go to this column to get the numbers. And for the activity-based method, we have the information over here. Now make sure when you're working on your homework assignment, look at numbers very carefully. Try and be as precise as possible. If the problem asks you to keep it to 2 digits, round it up to 2 digits. So read the problem very carefully and answer appropriately. Otherwise, you know, the numbers are going to be marked wrong. If you have any questions, please do send me an email and send it to me sooner rather than later.